Hi again. In this video we are going to look at the MBus Auto Discover tool in the Dingo Manager. I start by connecting to the Dingo device and navigate to the Peripheral Manager. Here I find the MBus and start the MBus Discover tool. I will start by explaining quickly the buttons within this tool. The Scan MBus button will simply scan for any MBus meters connected to the MBus plugin in the Dingo device and display these as lines in the grid, where the address is the secondary address. The Full Scan button goes further. It scans for MBus meters and probes them for detailed information, which will be displayed in the yellow columns in the grid. The Full Scan and Configure button goes all the way. It scans, gets the details and creates virtual BACnet devices representing the MBus meters and even creates trend logs ready to trend the data from the MBus meters. Actions can be run against the MBus meters, for example to acquire details. If we already know the secondary addresses for the MBus meters, then we can be prepared and assign names to the MBus meters by importing the already prepared file. We can also manually set the manufacturer and product information by browsing our repository over vendors and products. The same can be done in regard to the templates. We can do things manually by adding the lines to the grid and delete lines as well. Any changes can be saved at any time, and the grid can be refreshed at any time. But in this video we will use the full scan method. We start by clicking on full scan. We see in the background that the scan is finding some meters. When the scan is complete, we see that all details are also available. The only thing missing is the name. But I came prepared. I knew what the secondary addresses were for the meters and on what floor they are located. I made a file associating the address with the floor. I only need to import this file and save the changes. The found MBus meters have been linked to the correct peripheral template. If it had not, then we could browse for the correct template and use that. If the correct template does not exist, then we can use the payload read from the MBus meters to create a new template, but that is for another video. The only thing left now is to run the configure action on the lines. This will create the virtual BACnet devices for the MBus meters and create trend logs ready to use. When finished, we navigate to the BACnet setup. We find the active BACnet setup and find the MBus gateway that should contain the newly created virtual BACnet devices representing the MBus devices. And there they are. We also see that trend logs have been created and ready to use. We have our trend log pusher application running in the background, which is an application that can send the trend logs to any cloud interface, but in this case we use our own Go-IoT cloud. We will now take a coffee break. Hi again. In the coffee break, the trend logs have now been stored with data from the MBus meters. The trend logs can actually be configured to poll the virtual BACnet devices for data from the MBus meters or receive them when they change as change of value. In our case, the trend logs have been configured to use change of values. The trend log pusher that will send the data to the cloud is configured to send the data at a 15 minutes interval and with a 300 seconds offset, which means it will send 5 minutes past every 15 minutes. During the coffee break, the trend log pusher has therefore sent data a few times. I will now check the location where the data is stored in the cloud by refreshing this meters item in the tree. And we see that new meters have been added in the cloud. We see, for example, the floor names I assigned to them. If I check the data for these meters, then we see that they all contain data sent from the trend log pusher. Now we could call this configuration semi-automatic, where we in 2 steps configured the MBus. First we scanned, and second we ran the configuration action. Well, 3 steps if we include the naming. So, to summarize, we can do a fully automatic configuration of the MBus by only using the peripheral command application and the trend log pusher application, or we can do a semi-automatic configuration by using scanning, added templates and other things, apply actions, and using the trend log pusher application. The peripheral command application can then also be activated to automatically configure any later attachments of MBus meters. I hope you enjoyed this video. Bye bye for now.